Everyone. Thank you for joining us today. Um, just before we start, if you're actually joining for the first time, I would advise if you can just go into the settings and just ensure that you disable all the notifications and pop-ups so that they don't disturb you when you are trying to watch the session. So if you can just go to the settings and just ensure that all the notifications and pop-ups are disabled. Just want to check if everyone good. Thanks, Brian. Welcome everyone. My name is Barry. I am based in the South African office. Welcome to our topic today is low voltage switchboard design and construction verification. This will be presented by Ms. Alex Gregory, who is our EIT lecturer and ICOM principal engineer. Just the common questions that we normally get. If you are actually wondering about the certificate of attendance and copy of the slides, we will be sharing the webinar copy of the PDF and also the video in the next 1 to 2 working days. So if you can just also just check your emails. Sometimes it goes under junk or spam folder, so just check it there. We should be sharing that with you. And then once again, we provide free digital certificate of attendance for our technical webinars. So at the end of the session, I will be sharing a link or the QR code whereby you need to complete a short survey form. Then from there, you should be able to receive your certificate of attendance, which takes about 1 to 2 working days. Just for those who are actually joining us for the first time, just to give you a level about EIT, a high level about EIT is that we do specialize in the engineering courses. Courses starts from professional development programs all the way to Doctor of Engineering. And as you may know that, the industries are changing, job market is changing. At EIT, we are industry linked. So we do ensure that our study materials, our resources are up to date just to keep up with the trends. And then once more, just like any higher education provider or universities in Australia, we are accredited with Australian government, and you also find some of our courses that are actually accredited with international engineering bodies. And then we source our lectures from different parts of the globe to ensure that our students receive relevant education. So for now, I'm just gonna hand it over to Ms. Gregory. You can carry on with the presentation. Thank you.
Hello everyone, good afternoon or good evening or good morning, depending where you're dialing in from. And thanks for joining us today. So today's focus is on switchboards, all things switchboards. So we're going to just be running through some basics of different switchboard types, then looking at some design, and then for those who might be involved in design or construction or even maintenance, having a look at shop drawing reviews and then what to keep an eye out for inspections. So got some good information to go through today, and hopefully we've still got some time at the end for a bit of Q&A that you may have. So let's talk on the basics of switchboards. So when I say switchboard, it's anything that contains a protective device. So we could be talking main switchboards, which is the key ones for a whole building. You could have a switchboard associated with a generator. You might have smaller distribution boards located throughout a facility that distribute light and power. You might have heard the term panel boards, which are just your very small sort of 12 pole or, residential sized switchboards. You could have load centers, which are very similar to panel boards, or you can have switchboards that are dedicated to mechanical services themselves. Okay, so here we've got a couple of pictures of some different types of switchboards. Get my pointer out. So this could be what's described as a panel board or a little load center because it's fairly small. Here you can see you've got a switchboard with its main isolator as well as your chassis, which contains all of your little circuit breakers. This just shows a switchboard with some indicator lights. And over here we have again a little single chassis or a little 18-pole panel board or a load center with some power points hanging off it. So a switchboard will be defined by whatever your latest or your relevant standard is for electrical standards or wiring rules. But typically it's the enclosure that contains that protective switchgear. So we're talking fuses and circuit breakers. And that's what your switchboard is often defined as. And from there, you supply either submains or downstream circuiting. A distribution board is normally any other switchboard that isn't your main switchboard. So you'll have your main switchboard at the top, and then downstream from that you could have various distribution boards. So here, if we want to look at, say, a photo of a switchboard, we can identify a couple of key things. Where we have these silver handles, that's where you might pick that panel off, and we call those lift-off panels, as opposed to where you might have a door handle that would have hinges, that would be a door that swings open. Behind all of these cabinets would be some circuit breakers. Sometimes if you have really big circuit breakers like this one, it might be a withdrawable circuit breaker, which is a type of breaker where you can pull it out on rails. You can also see here by the screens a couple of energy meters, a couple of selector switches or isolators, and you can see we've got some wider tiers and then we've got some skinny tiers. These ones here are typically where all your cables go. So your cabling will come out of each breaker and then get out of your switchboard via this tier. Down the very bottom, it sits often on what's known as a plinth. And then as well, you've got, such as this, is the handle of an isolator, where you could isolate your incoming supply. So just by looking at this picture, we're able to sort of spot a couple of different components that make up a switchboard. So you can get different types of main switchboards. You might be familiar most commonly with a front connected switchboard. So essentially everything for that switchboard is accessed from the front. These are the ones that sit against walls, and often they're wider or longer in length. You could have a rear connected switchboard, which means you can access all your cables and the bus bars from the back of the switchboard. And all your switch gear is on the front, so it's like having both the front and the back of your board utilized. And as a result of that, your rear connected switchboards tend to be wider or deeper. Now the third term you might hear is form. So how you differentiate or segregate your circuit breakers from your bus bars will dictate what's known as the form of your board, and that's how the internals of that switchboard are constructed. So on the right here, you can just see a bit of a comparison in size between a rear access switchboard, which has, we can see here, 8 circuit breakers in each tier. It's about 1.2 meters wide. So it's narrower, but its depth would be a lot deeper. A front access, which is a lot more common, needs to account for cable space. So that's why they tend to get longer in length. So for the same amount of circuit breakers, a front access switchboard would be wider at 1.6 meters, but more shallow than a rear access board. So let's keep talking about terminology. What we can see here on the slide is just another picture of a switchboard. This one is actually a rear connected switchboard. So if you were to walk around the back, you could have a look and take off the hinged panels and see the bus bar network at the back. Another way to tell it's rear connected is we don't have any of those really skinny cable zones because they're buried in the middle of the board. So you can have multiple forms of segregation, and each one simply defines your separation between your functional unit, which is your circuit breaker, the bus bars of the switchboard, and then the terminals where you connect your external conductors, which is your cabling. So you would have your bus bar supplying your breaker, and then you would have your submain cabling connected to the other side of that breaker. Now, how each of these three things are separated will tell us what the form of the board is. So the switchboard form that has the least amount of separation is a form 1. And essentially, there is no separation between the bus bar, your protective devices, and your connected cabling. So there's no internal separation between anything within that board, and that would be a form 1. A form 2 is where we separate the bus bars from the functional units. So we don't care as much what we do with our cabled connections. Our form 2 only requires the bus bars from having separation to the functional units. Now a form 3 obviously is the next step up. And here we still have a separation from our bus bar to our functional units. However, we now have separation between our functional units. So they're separated from one another. Now again, we're not too worried about what happens with our cabled connections for a form 3. If we go the top spec of form, we're looking at a form 4. So we're building on from our form 2 and from our form 3. We have separation from our functional units to our bus bar. We have separation of our functional units from one another. But we also have separation of our cable connections from one another. So each outgoing circuit is entirely separated from one another. You may have separation here between the breaker and the connections, but the important part of a form 4 is this part here that we've added on to a form 3. So a higher form just means this circuit, if it was to have a fault, would be less likely to impact this circuit. So you've got better protection for all of your circuits. So Now that we've gone through the basics of switchboards, we've looked at some key terminology, we've looked at some basic forms, whether it's a front connected or whether it's a rear connected board. Now let's talk through a bit about how to design for a switchboard. So, what we always suggest is somewhere, if you are on the designing end of engineering, you want to specify what type of switchboard you want to use. And that, as an example, I've put up here a reference to 61439. That's both an Australian standard and an IEC standard. And it requires you to outline everything you want that board to have, from earthing, voltage, transient or temperature over voltage limits, what frequency it should operate, so all those technical specs so that your board can be built to suit your installation. Some key considerations when you are locating or designing a switchboard or even replacing a switchboard is to look at your relevant standards and work out where that board is going, how much space it needs, and that's not only does it fit in the room, but do you have enough space for both safety and for egress, so people escaping the room. Some common requirements that relate to switchboard locations and clearances that you may need to consider is if your switchboard is going in a corridor, you might want to seal the cupboard from smoke so that a fault on that board doesn't produce smoke into an egress path. You might not want doors opening onto your path of egress. If you have large boards, whether that's physically large or a high rating in amps, you might want that board to be further segregated from other things, because a fault on a higher rated amperage board could produce a higher energy. You may want to fire rate your switch room. You may want minimum lighting levels. You want to consider the door heights and dimensions of your room to make sure you can get that switchboard in and out. There's some key ventilation requirements. Or you might want to consider arc flash, whether you're detecting it or whether you're asking for a switchboard that can contain arc flash. So these are all things to consider when you're locating a switchboard somewhere. So for example, here is a rear connected switchboard. So we've got connections on the front and on the back. This is showing to Australian standards, and yours might be similar, that we need a certain amount of clearance in front and around that whole switchboard. Clearance in front of breakers, clearance in front of lift-off panels, clearance in front of doors when they're in their open position. So it's important to make sure you have enough space where you're locating these boards to your local requirements. This is an example if your switchboard is in an access way. So we require a meter in front of your switchboard or 600 in front of doors in any position. So if your door is bigger, you still need that clearance in front of the door, and that's to make sure if the doors are in the open position, people can still egress out of that area. If you have switchboards facing one another, then imagine you're opening the doors of both of those switchboards, and you want to make sure you have enough space remaining when those doors are open. Not only so that they don't clash, but so that you have enough space to get out of that plant room in the event of an emergency. So, other things to consider is how you would label your switchboard, because you want to know that it is an electrical switchboard. and you would like to know if it's a main switchboard or a distribution board or a mechanical switchboard. So information about that board should be clearly shown on the front, and that's what this label here is. Now we've spoken about clearances around your switchboard, but maybe you've got a situation where you have lots of space, but you want to provide mechanical protection in the event of forklifts or other machinery. So often the question is, how big is my switchboard going to be? And it can be often difficult to size a switchboard without actually knowing who would be building it. We need to know the switchboard size in order to size our room to make sure we have all those clearances. So often what you can do is come up with what we call a skeleton single line diagram for your main switchboard. So to do that, you'd need to work out how many distribution boards you are supplying from your main switchboard, because this will tell you how many outgoing circuits you have. Similarly, how many mechanical switchboards are you supplying from that main switchboard? What is your incoming power arrangement? You might have a generator, you might have two sources of supply. That will dictate how big your incoming supply tier would need to be. When you've got a rough estimate of your building load, that will tell you the amps that your switchboard may need to be rated to. And using all of these dot points, you could sketch out what your single line diagram for your main switchboard may look like. Then it's up to you to decide if you want a front connected or a rear connected board, like we've spoken about. If you want, essentially, it would mean a longer but narrower board or a shorter but wider board. You might want some spare circuit breakers so that you can expand in the future. And once you've got all of that, you could work out where your doors could go on your switchboard layout. So there's a fair few steps to go through to come up with that single line diagram to then go back and be able to size your switchboard. So you could do it a couple of different ways. You could use a spreadsheet if you have an idea of previous switchboard designs. You could go to a switchboard builder with your single line diagram and ask them to give you dimensions if they were to build it. That's probably the most accurate way. Sometimes there are online sizing tools from Schneider and similar companies that you could ask to size your switchboard. And you could go off some previous projects or some existing installations to get a feel for how big it would actually be. On the bottom right here is a little Excel sketch done up for a main switchboard. Typically, your incoming panels could be up to 800 wide, while up to 250 amps, you might have 600 wide tiers. Your cable zones are shown here are obviously a lot smaller. This sketch here is estimating about 2.8 meters for the main switchboard. And from there, the room has been sized. So you've got double doors to get your board in and out. You've got enough clearance in front of your switchboard for egress, and your wall is long enough to house that board. So this is a very rough check to size a main switchboard. Here's another example of the same tool, but with obviously 1, 2, 3, 4 cable zones, incoming breaker, and 3 tiers of outgoing supplies. So this project, we followed these 4 steps that we went through before. How many outgoing boards is it supplying, from light and power through to communications or mechanical? How big we think those supplies could be. And from there, we did a rough calc for a switchboard. The next step was to design the room. So you can see that switchboard was located against this wall, and then we double checked that we had enough room for double plant room doors, for other switchboards to have clearances. This is checking we have clearances in front of the switchboard doors when they're open to make sure our room is not too narrow. Here's another example. This one's showing that we're calculating the clearances in front of these doors from other switchboards. So it's making sure that we've got that 600 mil clearance when all the doors of that switchboard are in the open position. So if we want to size distribution boards, these are the next ones down. The process is very similar. Again, you work out how your DB is structured. Do you have a single chassis, or perhaps you've got 2, one for lighting and one for power? You'd need to know how many circuits you need, because this will tell you how many poles of your chassis. Is it 12, 18, 24? You could consult directly with NHP or with Schneider to find out the dimensions of typical distribution boards. You could look at similar installations. Typically, you allow for 600 mil tiers, so a single DB would be 600, a double or a 2 panel would be 1200. Also make sure you allow for space on either side of your switchboard in your cupboards. We normally allow 100 mil on the left and the right just to allow for installation. And lastly, if it's going in a cupboard, you want to consider that your doors are wide enough so that you can access your DB, and that it's deep enough to hold your DB in the cupboard. So here's an example of a distribution board cupboard. This one has a 2-tier or a 1200 wide distribution board, as well as 2 600 wide distribution boards. You can see there's 100 mil between each one. Our board is typically about 300 deep, so we tend to allow a 600 to 800 deep cupboard. And then the last check is make sure your doors are wide enough so that when they're open, you can fully access your distribution board and it's not tucked in behind a corner. So if we have finished designing our switchboard, then we will receive the shop drawings whilst it's being built. So essentially what you want to do is check off everything that you wanted in your technical specification. So you want to check your single line diagrams to make sure everything has been included that you need to. We're talking about meters, circuit breakers, surge diverters, spare spots. You want to check your technical specs, which would be in that document. So our form, like we've spoken about, how much amps it can handle, what the IP rating is, what fault withstand level the board has, and which standard it's complying to. You could even then check things like the color or the thickness of metal or the finish of the metal to make sure it looks like how you want it to. On the right here is a snip from a shop drawing. So all this information will be contained either in a table or in some general construction notes within that shop drawing set. So other things to keep an eye on is making sure the main switch height is low enough that it can be reached. So we say less than 2 meters. You want to check that your buses that make up your main switchboard all have enough current for what you need. You might have some location requirements. So if it's going somewhere that's earthquake prone, you might need restraints for earthquakes. If you have nominated exactly what protective devices you're after, then checking the shop drawings can help you make sure you've got the right trip unit or the settings documented on those shop drawings so that it is correct when it gets shipped. If you want some spares, check if you've got space for spares or if spares are provided on the board. And if we're looking about energy metering, you might have a specific type of meter you're after. Maybe you want kilowatt hour meters, or maybe you want a multifunction meter. So you want to check in that equipment list, like what's shown here, that it is correct. So your meter type, perhaps your surge diverter, your circuit breaker, you check the actual catalog numbers to make sure they're correct. So then we look at our switch room itself and make sure that what's shown on the shop drawing will actually fit in the room. And we still maintain those clearances that we wanted to be sure about. Then if your board's extra long, or you might have certain requirements around your cables. Are your incoming cables coming from underneath your switchboard or from overhead? And is the board designed for that? Now on the topic of labels, again, it's up to you what you want labeled, but typically we recommend, as we said, your main switchboard has a label, your main isolator has a label. You might want to label what everything is outgoing so you know where it's going to. And for distribution boards, you'd want circuit schedules. Maybe you've got some automatic controls that you want isolators for. Again, check that you've got enough spare space for future installations and that it all matches your tech spec. So this is an example of a design drawing where a lot of that information is shown. So we've got an isolator, 3 phases coming in. We have a kilowatt hour meter. We also have a surge protection or a surge diverter. This design has a 160 amp bus bar, fault withstand rating of 15 kA, and its size is 24 poles. So we would want to check all those things on the shop drawings. We're also shown we've got single phase outgoing supplies with 20 amp circuit breakers. These two have RCDs, so we would check those as well. It's an IP44 and a Form 4 board with a neutral and an earth bar and a controls section. So you could highlight off each of those parts against the shop drawings to make sure nothing's been missed. And your shop drawing might look something like this. So it takes that information and gives you a 600 by 1.2 meter distribution board. There's our isolator, there's our 24 pole chassis. We have some surge diverters and some section for controls. And then over here, we have that construction info, IP rating, form, amperage. So all of this, we're cross-checking against that single line diagram. So now imagine you've done your design, you've reviewed your shop drawing, and the board has been built, arrived, and been installed. So this is a distribution board. It's obviously wall mounted. Cables come in from the bottom and go out from the top. We've got our main label, and we've got some door handles here. Inside, we have some chassis, we have some breakers and isolators, and some control section down the bottom. So when we're inspecting a switchboard, you might be looking at an existing switchboard and maybe you want to get a feel for its condition. So compliance is different to condition. If we're looking at condition, we're talking about how old it looks, if it's clean or dirty. Maybe there's evidence of corrosion from the environment or damage, it's been knocked or chipped. You could check all the equipment visually works. So your meter, your surge diverter is healthy. You could ask those who use it if there's any fault or issues known with the board. Maybe it's making a buzzing noise. But the key safety factor is you do not open a live switchboard, especially if internally it does not have segregation from you and things that are live. So this slide, which will be in the slide deck, simply outlines what information you could gather from a visual inspection. So where is your mains cabling coming from? Above or below? How much clearance do you have existing in the room? Hopefully the board is labelled and can tell you some information. There might be a single line diagram that's available. Again, we look at that condition list we just went through, or look at the brand of circuit breaker types. Maybe you've got cable info or some IP rating that's identifiable. You could also check to see what components are in there. So is there meters and surge protection devices? Is there evidence of arc flash containment? All this information will help you understand what the existing switchboard includes. So, if we were to inspect this switchboard, we can see we've got meters, big withdrawable breakers, some cable zones, other meters, and over here what looks to be some spare spaces. So if we're looking at a DB, which is these smaller switchboards, we could check if there's RCDs on some or all of the circuits. Maybe there's a circuit schedule on the inside of the door that would tell us a bit more about it. We could certainly look to see what brand of breakers have been installed, or maybe where that board serves. We could look at the size of this chassis and see how many poles it has and how many are spare. Maybe there's a manual test function for emergency lights, or what size is our isolator. So we can get a lot of information from a visual inspection. Again here, we have an isolator. We could look at the size of it. Here is our chassis with spare down the bottom here, and these ones are used. We've got a few controls and a meter and a surge diverter. This one also has a circuit schedule on the inside of the door. Maybe you have clearance issues, such as we've shown here. If you think back to that diagram, opening all these doors is going to block this narrow hallway, so we don't have enough clearance from here to here. Similarly on this side, we check our existing clearances here. Obviously this has a fault sticker indicating something's locked out and might show to us that there's a problem. Here is again a picture of that withdrawable circuit breaker type. Often indicator lights might tell you the health of that circuit breaker and its operating status. If you can't open a switchboard, there might be viewing windows provided for things like the surge diverter or the meter. And you can use that to see in safely. Here are two isolators with some control cabling. Obviously this is all exposed and was taken when the board was dead. So you wouldn't be wanting to look at this without a barrier between you and live services. But behind what's known as the escutcheon that sits on the front, this is what the switchboard could look like. We've got our chassis, we've got our incoming power, 3 phases to power that chassis, and some control signaling. Here's another one, 3 phases of power. To this, you might also hear the term bus comb, very similar. This one has 3-phase circuit breakers installed, so you can see each one takes red, white, and blue. Over here, you can see we have a few red labels. These are main switchboard labels. Couple more photos. This is a switchboard in a cupboard. You can see we have lots of clearance on the left and right, and this is sitting on the ground. So all our cabling is coming in and exiting from the top. If you were to look closely at a circuit breaker, you might find that it has these ability to set the settings. So perhaps you want to check those settings in your inspection to make sure they are correct. If you see something like this though, my suggestion is that you don't go near it and that you stand back from something as old and as exposed as this switchboard. So, in summary, when you're looking at switchboards, you need to have a clear understanding of the purpose of that board and then the type of switchboard you're going to use, whether it's main, distribution, mechanical, front, rear. Have a check of your switchboard in terms of its size, where you're putting it, and then think of those clearance and labeling requirements that you might want to do. If you're designing a switchboard, it is your responsibility to also check that the shop drawings are correct, so what you're getting matches what you were intending. And lastly, if it's possible, check what's being constructed after the fact to again make sure everything's been carried through correctly from design through to build through to installation.
All right. Thanks once again, Alexandra. So just to those who want just to see our schedule, we've got professional certificate of competency, professional of circuit breakers. Those programs will be starting because 17th of April and the 24th. Our graduate certificate in renewable energy will start on the 2nd of May. And then our advanced diplomas, electrical engineering on the 6th of June. We've got also our professional certificate of competency on the 12th of June. Our postgraduate programs, graduate certificate, the graduate diplomas and masters will be starting on the 26th of June. undergraduate programs will be starting on the 24th, and then all our on-campus programs will be starting on the 31st of July. So you can always just click on the link or just go to EIT under course schedule just to read more about the programs that will be starting sooner. All right, and then once again, our upcoming webinars, basic of process control and loop tuning. This will be taking place on the 19th of April. So you can always just go under EIT and news events in order to be able to sign up for this webinar. Yes, for those who have been asking about the digital certificate of attendance, so if you can just take this moment and just scan the QR code, or I will alternatively just share the link in the chats. So just follow the link. There will be a form that you need to complete. If you can just complete that in order to receive your certificate of attendance, or you can just scan the QR code. Right. Just checking, there's a couple of questions that came through. We can have those questions again. Our lecturer is still here to assist.
So I saw that there was a question from Navid. Yes, no one shouldn't work on a live switchboard. You're correct. The Form 4 is about your continuity of supply. So by having things segregated from one another, such as in a data center, a fault on one is not likely to affect another service. So it's more protection of your equipment. Test check. So Brian, what test check should you do on an LV switchboard? So it depends on the standards that you work with. For us, we do things like de-energization tests. So we do polarity checks, we do insulation resistance checks, we test all the sub-mains, we make sure everything's operating as it should from a functional perspective. Just reading through the questions. A rear-facing switchboard does require the same distance at the back. So just like it has panels on the front, you need to maintain that clearance if you have a rear switchboard or a back connected switchboard.
Just to add this one to Mark, so far we haven't got another date for that professional certificate. However, as soon as we have the new dates, we should be sharing the information. Thanks, Mark.
Bus bar visual checks by Terence. If there's any issues with the insulation around your bus bar, obviously if it's warped, if it has burn marks, if its shape has changed, that's all indications that it's not operating well. Otherwise, you can do thermo testing, which will tell you if there's any extra or residual heat on your bus bar. Elisa has asked about clearance supply in vessels. I'm not actually sure what you mean about vessels in that instance. If it's something that contains switch gear, then it is a switchboard, so the same clearances for switchboards would apply. So I think that might be all the questions technically from, how are switchboards priced? By switchboard builders. So that's a very, I guess, specific question to your location and also your industry. So the best people to give you quotes are those that build them. Navid has two more questions. For withdrawable breakers, yes, the clearance is taken from when that switchgear is in the racked out position. So you need to pull it all the way out, and then you measure your clearance from in front of that. Now, the highest amperage of LV switchboard that's tested, again, it depends on your location. For Australia, anything up to 1,000 volts is considered low voltage. After that, we consider it high voltage, but it might be different in your country. Arc flash boundary, Brian, hasn't been covered in today's webinar. That's a different topic. Essentially, you need to calculate or have calculated the energy during a fault, and it will give you a distance, and that distance is a boundary. But that's a more complicated question, and there was actually a whole webinar done for EIT on that topic that I'm sure could be available. Eric, Form A and B. So that's if you have, say, 3A or 3B. If you have a look at the details of the forms, they're just two different variances in each form type. So they still satisfy the requirements of, say, Form 3B, but they might have extra segregation between terminals. And if you're using IH, that's using insulation and housing, which is using insulating material or putting things in enclosures to satisfy Form 3B. So IH just stands for insulation and housing. Jonah, diverted neutral currents aren't really covered in switchboard design today, so that question I'll need to take on notice. Segregation could be a compartment. It could be, as we said, insulation, so actual bus bar wrap. It could be, for the purpose of switchboard standards, air gap is not considered segregation. So it's either a compartment, a housing, or insulation. Gabrielle, on your question, there's nothing to my knowledge about having to report unprotected boards. If you're talking about Form 1, it might come down to where it's being installed, and there could be local council or client requirements that say you are or are not permitted to have a Form 1 board. Hezron, your question on bus bar. Your switchboard builder will tell you what the amperage is, 400 amps, 800 amps, and then it's up to the designer or the switchboard builder to make sure the load or the bus bar is suitable for what that load is. Now, switchboards typically have a lifespan in the LV world of about up to 30 years. After that point, we tend to say they should be considered for replacement. Kennedy, ambient temperature does influence switchboards. It depends on which standard you're designing to. There is limits on what that internal ambient temperature can be and can exceed before it needs to have either extra space, which makes it bigger, or ventilation. Now, the switchboard standard for Australia is 61439. So all switchboards built and tested for Australian use must satisfy that particular standard, which I'll write in the chat box in case anyone wants to look it up. And lucky last question. Sorry, 3 more questions and then we're done. As a board manufacturer, what do I consider when pricing, or can you arrange another webinar? Again, pricing of switchboards comes down to those who build them. That's not something that designers can comment on. It depends on the designs they use and the construction cost of their materials. And Navid, for your same answer to your question, 61439 is the standard. Nothing else is considered acceptable, nor is AS 3439, which Steely has asked, as that's now, that standard has been superseded. And lucky last question for the webinar. Zibs, IP rating depends where it goes. Externally, I'd suggest 56 or higher. Internally, we typically use 42, but it's up to you and what your application is. Thanks, everyone.
Thanks, Alexandra. Thanks for everyone who joined, and have a great day further. Thank you.